Hello everyone, I'm Wenyan Ru. I want to share data mining project about a prediction of online shops purchase intention. There are four parts: introduction, data collection and preprocessing, mining methodologies, and conclusion. With the aid of technologies and the wide coverage of mobile devices, online retail is more and more popular shopping model. Compared with the traditional retail, online sales cannot directly interact with consumer, which made it hard for sales to identify clients' intentions and hesitation to make purchases. So the objective of data mining is to build simple prediction models to help sales focus on the relevant data of consumer purchase intention and simply predict whether consumer will buy the product or not, to help operators optimize the online sales strategy and achieve high gross merchandise value. Move on part 2. This report uses public data sites, which can be downloaded directly via this website. There are 12.33 thousand instances, and 84.5 were negative class samples that did not end with shopping, and the rest were positive class samples ending with shopping. The original dataset consists of 10 numerical and 8 categorical attributes. To divide the groups in next step, a new feature named average product duration is added in dataset, which means average time in seconds a consumer spends on a product page. This table shows 11 numerical attributes description, minimum value, and maximum value, and standard version. And this table shows 8 categorical attributes description and number of categorical values. The revenue attribute is used as a class label. Firstly, do discretization for dataset. Site find number bins as true. The system will find suitable number of groups. As a result, group consumers into 4 equal-wise average product duration. We can say the most of user in group 1 in which customers stay on a product website for no more than 141.1 seconds. And then do normalization for 3 attributes: administrative duration, informational duration, and product-related duration, because the differences between the maximum and minimum values are large. Use min-max normalization with a minimum of 0 and a maximum of 1 for those of attributes. And then standardization are the numerical variables, except 3 attributes I mentioned in last slide. Those of attributes are standardized to a standard normal distribution with mean 0 and variance 1. To convert the categorical attributes into a form that can be processed by mathematical model in the following steps. I create 3 dummy variables: running visit, new visit, and other. To select attributes, correlation attribute eval and infogain attribute eval, 2 methods are used to select variables. The top 10 variables are selected for each method. Finally, 14 variables are returned in dataset. And then dividing dataset to training dataset and testing dataset. Due to the relatively high concentration of data in group 1, here stratified sampling is used to keep each classification feature from being missed. Dividing dataset into 2 subsets in 80% as training set and 20% as testing set, respectively. Move on part 3, mining methodologies. There are several mining methodologies like decision tree Bayesian, clustered analysis, neural networks, and others. With respect to the objective of this case, neural network model and decision tree are selected. Decision trees are suitable for business problems due to the advantages of predicting small data sets, and the results are simple and easy to describe. The right area is involving calculation formula in say 4.5 algorithm. Based on this algorithm, choose J48 in VCA. Importing training dataset into decision tree training model, adjusting the number of decision tree leaf. The results in below table, saving the decision tree model with the highest accuracy, 92.11%. Another mining methodology is neural network. One of the main advantages of it is it can handle nonlinear problems and perform well with large amounts of data with high model stability. Operators can use neural network models when dealing with long-term problems with large datasets. The right area is common loss function, mini-square error. Importing training dataset into a neural network training model, adjusting the related parameters. The results are shown as below table, saving the model with the highest accuracy, 92.92. To check the accuracy of the decision tree and neural network model, they were testing using the previously divided testing set. And the right picture are outcomes of decision tree and neural network respectively. And we can say the accuracy of decision tree is around 96. True positive rate is 0.966. And the accuracy of neural network model is around 97. True positive rate is 0.978. So what problems can be solved by these models? Based on exit rate pages, time spent on the product page, bounce rates, whether the visit is a returning customer or a new customer, and other factors that will influence the customer's purchase behaviors. The e-commerce operators could make actions respond those of strongly correlated factors to achieve both sales. The models predict whether a consumer will make a purchase on e-commerce platform. Finally, I want to make a conclusion. In this report, two simple models for user behavior analysis were constructed for an online shopping platform, including decision tree and neural network model. Experiments use data from online retailers to predict the purchase intention of the visitor. Where two models perform well, their points can be improved. I noticed that in testing stage, a lot of instances are missing. One possible problem is a class imbalance. This is because the number of negative class instances in the dataset is much higher than that of the positive class instances, and the imbalanced success rates on positive and negative samples show that the classifier tend to label the test sample as a majority class. This class imbalance problem is a natural situation for the analyzer problem, since most of e-commerce visits don't end with shopping. Oversampling is a possible solution for this question. And another issue is neural network training time is too short. That's all about my presentation. Thank you for listening.